Today's topic is higher order linear differential equation with constant coefficients. So the general form of this linear differential equation with constant coefficient is a naught into d raised to n by dx raised to n of y plus a1 into d raised to n minus 1 by dx raised to n minus 1 of y, etc. up to a raised to n into y is equal to q of x. So this d by dx can be rewritten as d, which is the derivative operator. So the above equation will turn off to a naught into d raised to ny plus a1 d raised to n minus 1 into y plus a2 into d raised to n minus 2 into y, etc. up to an into y equal to q of x. So from this term we can take y common and it would be of the form like this: y into a naught into d raised to n plus a1 into d raised to n minus 1 plus a2 into d raised to n minus 2, etc. up to an, that is equal to q of x. So this term in this bracket is written as f of d into y equal to q of x, where this f of d is a polynomial in d of degree n, or f of d is a function of d and q of x is a function of x, and this is the general form. Now the solution is given of the form y equal to cf plus pi. This cf means complementary function. Cf is complementary function and it is the solution of the equation f of d into y equal to 0. And pi is the particular integral, which is the equation is given here 1 by f of d into q of x. Now we see the methods to find the complementary function. Now to find the complementary function, we have to put this equation, we have to convert this equation into a homogeneous function, that is we have to put f of d into y is equal to 0. And now we have to form an auxiliary equation by putting d equal to m. Instead of d we have to substitute here m, and we can write f of m is equal to 0. And now we solve that equation and we have to find the roots. Now there are different types of root and we have different types of complementary function according to that. So if the roots are real and different, that is we have two real and different roots, say m1 and m2, then we will write as cf is equal to c1 e raised to m1 x plus c2 e raised to m2 x. Now according to the power we will be having as number of roots as the power, then it will be like as much as times we will increase the terms. That is, if there is 3 roots, then it is c1 e raised to m1 x plus c2 e raised to m2 x plus c3 e raised to m3 x. And now the second case is real and equal roots, that is m1 equal to m2 and that is equal to m. Generally we are considering it as m. The complementary function for that is c1 plus c2x into e raised to mx, or we can write this as, if we open the bracket it would be c1 e raised to mx plus c2x e raised to mx. And if we have 3 roots and the 3 are equal, means complementary function is c1 plus c2x plus c3x square into e raised to mx. If we have 4 function, means c1 plus c2x plus c3x square plus c4x cube into e raised to mx. Okay, and then we have the third one, that is imaginary and different. Imaginary and different roots, that is of the form alpha plus I beta, alpha plus or minus I beta. Then the complementary function will be e raised to alpha x, that is this alpha x into c1 cos beta x, this beta plus c2 sin beta x. The roots are imaginary and equal, that is alpha plus or minus I beta repeating twice. Then the complementary function is e raised to alpha x into c1 plus c2x into cos beta x plus c3 plus c4 x into sin beta x. Okay, so the complementary function is e raised to alpha x into c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. Now the method to find the particular integral, and depending on the form of the function of q of x, there are 6 different cases, out of which the first 3 cases are very important, that is exponential case, the sine and cos, that is trigonometric, and the algebraic case. We will look on to one by one. So we know that the general equation for the linear differential equation of constant coefficient is f of d into y is equal to q of x into e raised to ax, and if the q of x is of the form e raised to ax, the equation for the particular integral is 1 by f of d into q of x, that is here we substituted e raised to ax, and we have to substitute, to find the answer we have to substitute d equal to a. In the equation wherever d is coming, we will substitute there as d equal to a, and the denominator should not be 0. The denominator should not be 0, and if the denominator is 0, we will multiply the numerator by x and we will take the derivative of the denominator. Okay, so if q of x is equal to e raised to ax, we have to find the particular integral. The equation is 1 by f of d into e raised to ax, and we have to substitute d is equal to a. Now the second case is q of x equal to sine ax or cos ax. So then the particular integral equation will be 1 by f of d into sine x, or p of pi is equal to 1 by f of d into cos ax, and here we have to substitute d square as minus a square, not d, it is d square as minus a square, provided that the denominator is 0. Okay, then the next case is case number 3, that is q of x is equal to x raised to m, and here as done above, particular integral is equal to 1 by f of d into x raised to m. Now what we have to do is we have to take the least degree term common from f of d and use binomial expansion method. So in f of d, when we use the equation, we have to take the least degree term common from this f of d, and remaining we have to use binomial expansion method. The main two equations that you should remember is 1 plus x in the whole inverse is equal to 1 minus x plus x square minus x cube plus x raised to 4, etc. And 1 minus x, the whole inverse, not like this, whole inverse is 1 plus x square plus x cube plus x raised to 4. Now the case for us, q of x is equal to e raised to v of x. Here v of x could be sin ax, cos ax, or x raised to m. So if this is the form, then pi is a particular integral equal to 1 by f of d into e raised to ax of v of x. What we have to do is we have to take the e raised to ax common outside, and we have to substitute the d as d plus a, the a from this e raised to ax into v of x. Now v of x is sin ax, cos ax, or x raised to m. So we could apply case 1, 2 or 3 here. Okay, we have to keep in mind that we have to add a to the d. We will substitute d as d plus a. Now case number 5 is q of x is equal to x raised to v of x. Now here v of x is either cos x or sin x. We will not substitute x raised to m for this v of x. Then the particular integral equation is 1 by f of d into x raised to v of x. That is, what we will do is we will subtract x minus f dash of d by f of d into 1 by f of d of v of x. Here we could substitute case number 2 and we will continue. What we have to do is take this x outside, subtract it from the derivative of the denominator by the denominator. Okay, and the case number 6 here is q of x is equal to x raised to n v of x. Here also v of x is either cos x, cos ax, or sin ax. So here what we have to do is we have to convert this into the exponential part. So we know that e raised to I theta is cos theta plus I sin theta. So cos theta here is the real part and I sin theta is the imaginary part. So if the equation is 1 by f of d x raised to n sin ax, then sin ax is the imaginary part. That is, so imaginary part, we will substitute sin ax as imaginary part of e raised to I ax. Here I theta, theta is substituted by ax, so we will substitute here as e raised to I ax. Then the particular integral would be integral part of 1 by f of d e raised to I ax into x raised to n. Here we can apply case number 4. Similarly, if it is cos ax is the real part, so rp of e raised to iax. Then we'll take the rp of outside and 1 by f of d e raised to iax into x raised to n. So both the cases till here we can use the case number 4 to continue the questions. Now we will do some problems. So the first question is d square minus 3d plus 2 into y is equal to e raised to 3x. This is of the form f of d into y is equal to q of x. Here q of x is e raised to 3x. So to find the auxiliary equation, first we have to write f of d is equal to 0. That is d square minus 3d plus 2 is equal to 0. To write the auxiliary equation, we have to substitute m instead of d. So that is auxiliary equation is m square minus 3m plus 2 equal to 0. So the roots are m is equal to 1 and m is equal to 2. Therefore, the CF is equal to, complementary factor is equal to C1 e raised to x plus C2 e raised to 2x. That is of the form C1 e raised to mx plus C2 e raised to mx. C1 e raised to m1x plus C2 e raised to m2x. Then to find the particular integral, pi is equal to 1 by f of d into q of x. That is equal to 1 by d square minus 3d plus 2 into e raised to 3x. Now e raised to 3x is the first case. What we have to do is we have to substitute d as a, that is d as 3. So 1 by 3 square is 9 minus 9 plus 2 into e raised to 3x. That is 1 by 2 e raised to 3x. So pi is 1 by 2 e raised to 3x. So the general solution is y equal to cf plus pi. That is equal to, cf is c1 e raised to x plus c2 e raised to 2x. That is c1 e raised to x plus c2 e raised to 2x plus particular integral is 1 by 2 e raised to 3x. So that's the answer. Now this is the next question. D square minus 4d plus 1 into y is equal to cos 2x plus x. This is also of the form f of d into y is equal to q of x. That is q of x here is cos 2x plus x. Now to find the auxiliary equation, f of d is equal to 0 and that is d square minus 4d plus 1 is equal to 0. To write the auxiliary equation, substitute d as m, that is m square minus 4m plus 1 is equal to 0. The roots are m is equal to 2 plus or minus root 3. The root is m is equal to 2 plus or minus root 3. They are real and different roots. So CF is equal to C1 e raised to m1x, that is 2 plus root 3 into x plus C2 e raised to 2 minus root 3 into x. Now to find the particular integral, pi is equal to 1 by f of d into q of x, where f of d is 1 by d square minus 4d plus 1 and q of x is cos 2x plus x. Now we have to separate this, that is cos 2x by d square minus 4d plus 1 into plus x by d square minus 4d plus 1. So this is now the second case and this is the first case. So in second case we have to substitute d square as minus of a square. A is here 2. So that is equal to cos 2x divided by minus 4 d have no substitution, so d plus 1, and here it is x, we have to take the least degree term outside, but here there is no need, we can write it as 1 plus d square minus 4d, like this. Now this will be cos 2x by minus, we will take common outside, so 4d plus 3, and here we can take this into the numerator, that is 1 by d square minus 4d the whole inverse into x. Now to solve this, we have to multiply numerator and denominator with the conjugate, so it is cos 2 minus cos 2x into 4d minus 3 by 4d plus 3 into 4d minus 3 plus this is of the form 1 plus x inverse. So 1 plus x inverse, the expansion is 1 plus x inverse is equal to 1 minus x plus x square minus x cube plus x raised to 4, etc. So here first we have to see the outside term, how much time it is differentiable. Here x is only differentiable one time, so we have to write only one term. So that is 1 plus x inverse is equal to 1 minus d square minus 4d. Okay, 1 minus d square minus, now into x. Now this we can write as we can open the bracket, before that minus cos 2x into 4d minus 3. This is of the form a plus b into a minus b, that is a square minus d square, that is 16d square minus 9 square. And here we can open the bracket and put this x inside, so it is x minus d square x minus plus 4dx, opening this bracket and also putting the x inside. So here we have to substitute the value for d square as minus a square, so this will become cos 2 minus cos 2x 4d minus 3, and it is 16 into minus 4 minus 81, that is minus 73, plus x minus d square means d by dx of d square by dx square of x, so 2 times derivation it is 0, and here it is 1, so 4 into 1. Okay, so this will become, we can open the bracket also, this minus and minus cancel, so 4d cos 2x minus 3 cos 2x divided by 73 plus x plus 4. Now derivative of cos 2x is minus 2 sin x, so this will become minus 8 sin 2x minus 3 cos 2x divided by 70 into 1 by 73 into this plus x plus 4. So this is pi. So the general solution is general solution is y is equal to cf plus pi, particular integral, that is cf here is c1 e raised to 2 plus root 3 into x plus c2 e raised to 2 minus root 3x. So c1 e raised to 2 plus root 3 into x plus c2 e raised to 2 minus root 3 into x plus I'll write down 1 by 73 minus 8 sin 2x minus 3 cos 2x. Now this is the next question, d square minus 2d plus 1 into y equal to x into e raised to x sin x. So this is also of the form f of d into y is equal to q of x. To find the auxiliary equation, we have to put f of d is equal to 0, d square minus 2d plus 1 is equal to 0, substituting m for d, then m square minus 2m plus 1 is equal to 0. Here m is 1 comma 1. Therefore the CF is equal to c1 e raised to mx plus c2 x e raised to mx, that is 1x. Okay, now to find the particular integral, pi is equal to 1 by f of d into q of x. that is 1 by d square minus 2d plus 1, and here q of x is x into e raised to x into sin x, x e raised to x into sin x. Now this is of the form, this is of which case? This is of the form 1 by f of d e raised to ax into v of x. V of x may be any of this. So we can write it as, first what we have to do is we have to take the e raised to x outside. So e raised to x outside, and we have to add, change the denominator as d, substitute d as d plus a. Here a is 1. So d plus 1 the whole square minus 2 plus 1. So this will become d square, this will become x into sin x. Sorry, there is a mistake. 2 into d plus 1 plus 1. Okay. Then we have to simplify this bracket. E raised to x 1 divided by d square plus 2d plus 1, and this is minus 2d minus 2 plus 1. So this will cancel, this will cancel, x sin x. So it is e raised to x 1 by d square x sin x. So I told if numerator, there is d in the numerator, that means differentiation. When it is there in the denominator, it is integration. So e raised to x 1 by d, here d square, so we have to integrate 2 times. So it is x sin x, which is equal to e raised to x, here dx, so which is equal to e raised to x into 1 by d, applying integration by parts, x into minus cos x minus minus cos x dx, minus cos x minus 1 into minus cos x dx. This can be written as, that is equal to e raised to x into 1 by d minus x cos x plus sin x. That is equal to e raised to x integral of minus x cos x plus sin x. That is equal to e raised to x, again applying product rule, integration by parts, it is integral of minus x cos x dx plus integral of sin x dx. Okay, that is equal to e raised to x minus x into sin x minus integral 1 into sin x dx minus of cos x. This integral sin x is minus cos x here. So that is equal to e raised to x minus x sin x minus cos x, that is minus 2 cos x. So pi is equal to this. So y, general solution y is equal to cf plus pi. Cf is c1 e raised to x plus c2 x e raised to x plus this would be, this is minus, we will take minus common outside, e raised to x x sin x plus 2 cos x. This is the answer. So this is the next question, d square minus 1 y into x sin x. So this is also of the form f of d into y is equal to q of x. To find the auxiliary equation, f of d is equal to 0. That is d square minus 1 is equal to 0. The auxiliary equation here would be substituting m for d, m square is equal to 1 and m is equal to plus or minus 1. So the roots are real and different, therefore CF is equal to C1 e raised to x plus C2 e raised to minus x. To find the Pi, the equation is 1 by f of d into q of x. 1 by f of d is d square minus 1, and here q of x is x into sin x. So this is of the form x minus p of I equal to 1 by f of d into x v of x. Here v of x could be cos ax or sin ax. So we have to subtract x minus f dash of d by f of d into 1 by f of d into v of x. So we will write opening the bracket. Okay. So that is then on substituting, it would be x into 1 by d square minus 1 into sin x minus 2d by d square minus 1 the whole square sin x. So here d square is substituted as minus a square. So applying the value 1 by minus 1 sin x 2d on expanding this one, it is d raised to 4 minus 2d square plus 1 into sin x. So this is equal to minus x by 2 sin x minus 2d. So this is d square into d square, so minus 1 into minus 1 minus 2 into minus 1 plus 1 sin x. So that can be written as minus x by 2 sin x minus 2 by 4 cos x. So this can be simplified as minus x by 2 sin x minus 1 by 2 cos x. So the general solution is y is equal to CF plus PI. CF is C1 e raised to x plus C2 e raised to minus x minus x by 2 sin x minus 1 by 2 cos x. That's the final answer.